Let us try to clarify the concept of phase lag lead. Try to understand the meaning of phase lag or lead. For the sake of convenience, we have kept sin omega t as the reference. What it means, let us suppose you have alternating EMF which is being expressed like this. It is starting from 0. This side you have plotted, say, time or omega t, whatever you can say. You have plotted. If you are plotting omega t, that means angle has been plotted. Now, if you are keeping this as a reference, so remember that this graph is representing E naught sin omega t, and this graph will be taken as a reference. Always E naught sin omega t is taken as a reference. Now let us suppose you have an equation of the current which is like this. आप इमेजिन करें कि एक करंट है जो बिगिनिंग में थीटा एंगल से स्टार्ट हो रही है. देन यू विल फाइंड दैट दिस करंट विल बी रिप्रेजेंटेड एज आई नॉट साइन ओमेगा टी माइनस थीटा. यहां पे अगर आप ईएमएफ को देखें तो ये ई नॉट प्लॉटेड है. दिस साइड ऑन द एक्सिस हमने ईएमएफ या करंट किसी को भी प्लॉट किया हुआ हो सकता है. यू अंडरस्टैंड? हम इन दोनों का कोरिलेशन आपको दिखा रहे हैं कि ये जो करंट आप देख रहे हैं दैट इज थीटा डिग्री अहेड. हर जगह पे आप देख सकते हैं, अगर ये यहां से थीटा एंगल आगे है तो यहां से भी ये थीटा एंगल आगे होगा, एंड सो ऑन. इफ यू ट्राई टू सी द एक्सप्रेशन ऑफ दैट, देन इसमें ओमेगा टी के बाद माइनस थीटा आप यूज करेंगे, एंड दिस करंट विल बी कॉल्ड द लैगिंग करंट. इसकी ग्राफिकल रिप्रेजेंटेशन इस तरह से होगी. दिस विल बी अ लैगिंग करंट. यू अंडरस्टैंड? हम कहेंगे कि करंट इज लैगिंग द ईएमएफ बाय एंगल थीटा. दिस इज द लैंग्वेज यू विल बी यूजिंग. एंड इन केस द करंट इज लीडिंग, देन इट्स ग्राफिकल रिप्रेजेंटेशन विल समवेयर हियर. आप अगर ऐसा देखते हैं कि एक ऑल्टरनेटिंग करंट हमारा यहां से स्टार्ट हो रहा है, विच इज एंगल से -5. यू अंडरस्टैंड? एट t इज इक्वल टू 0 और ओमेगा टी इक्वल्स टू, बिगिनिंग में आप देखें तो इसकी वैल्यू -5 से स्टार्ट हो रही है. दी पीक वैल्यू हियर यू कैन रिप्रेजेंट एज आई नॉट. अगर आप इसकी पीक वैल्यू को I1 शो कर रहे हैं, देन द इक्वेशन फॉर दिस ग्राफ, जो ग्राफ पहले से स्टार्ट हो गया है, इक्वेशन फॉर दैट विल बी I1 साइन ओमेगा टी प्लस 5. अंडरस्टैंड? ये जो आप ग्राफ देख रहे हैं इसकी इक्वेशन ऐसे लिखी जाएगी, एंड चूंकि वो पहले से स्टार्ट हुआ है इसलिए इट विल बी कॉल्ड लीडिंग ग्राफ. इफ यू यूज द लैंग्वेज फॉर दिस करंट, then you will say that it is leading the EMF. It is leading the EMF by angle phi. This is the way you can express the lag and lead in EMF and current. For the sake of simplicity and convenience, we always take sin omega t as the reference. E naught sin omega t will be a better reference for the EMF, and with respect to that, you can show the lagging or leading current. In case the current is in phase, then it will be starting at the same point where the EMF has started. अगर करंट को सेम फेज में दिखाना होगा, then it will starting at this point itself. यहां से आप स्टार्ट करके सेम फेज के करंट को दिखाएंगे. In case the current is starting off earlier, then you will be calling it leading current. In case the current is starting off later on, then you will be calling it lagging current. You understand? Now, once we have introduced ourselves to the method in which you can express the magnitude of alternating current and the method in which you can show the direction of current. करंट के यहाँ पे डायरेक्शन के नाम पे हम उसे फेज लैग और लीड के टर्म्स में दिखाते हैं. Once you have introduced yourself to such concepts of magnitude and direction, Then let us check one by one that whenever this alternating currents are subjected to different elements, then what is the kind of currents you are getting, what is the phase lag and lead available. And there is some important concept which you call phasor diagram. So how you can express in a phasor diagram all such events. So first let us introduce this alternating currents to a circuit in which you have only resistors. Then we will be introducing it into an inductor, and then we will be dealing with the concept of a capacitor. Let us do that. Let us first introduce a pure resistor through an alternating EMF. You understand? You have an alternating EMF, say E naught sin omega t. The symbolic representation of alternating is this wavy line. Imagine that you have an alternating EMF E naught sin omega t, which is getting subjected to a pure resistor. Pure resistor means along with this resistor you do not have any other component. यहाँ पे सिर्फ resistance लगा हुआ है, and you are expected to get the value of current which will be flowing into this. Then you see, as per Ohm's law, in case you invoke Ohm's law, then it had said that the value of current is simply EMF upon resistance. यहाँ पे resistance की value constant है. This E is the instantaneous value of EMF. So ये जो current होगा ये भी एक instantaneous value of current होगी. The expression is very simple. This can be written as E naught sin omega t upon R, and it can be further simplified and written down as I naught sin omega t. Understand? So whenever you are subjecting a pure resistor to an alternating EMF, you will find that the current is simply E naught by R. अगर आप current की peak value निकालना चाहते हैं, अगर आप current की peak value निकालना चाहते हैं, तो this will be peak value of EMF upon resistance. And in case you want to calculate the RMS value, तो RMS value के लिए आपको EMF की भी RMS value लेनी होगी, and that will be giving you the RMS value of current. Nothing different in it. The very interesting fact here is that you can see the phase of current and phase of EMF. EMF में भी you can see ओमेगा टी के बाद यहाँ पे कोई भी एंगल इन्वॉल्व नहीं है, और यहाँ करंट में भी ओमेगा टी के बाद कोई एंगल इन्वॉल्व नहीं है. So the conclusion is that conclusion आपका कुछ इस तरह का है कि peak value of current is peak value of EMF upon resistance. In case you are trying to represent it in terms of RMS value, then RMS value of current will be RMS value of EMF upon resistance. Resistance अगर एक प्योर रजिस्टर की तरह है तो you can understand its behavior is something like the way you have seen in direct current. AC और DC में रजिस्टर का behavior same है. Second conclusion you have that the current is in same phase with EMF. Current is in phase with if you try to express this statement in terms of a diagram, then you can say that if with respect to time you are plotting the reference EMF as like this, if अगर हमारे पास alternating EMF की expression ये है, then the alternating current or instantaneous current which will be flowing into this circuit, that is in phase. फेज का मतलब दोनों ही एक पॉइंट से स्टार्ट होंगे, दोनों ही एक पॉइंट पे मैक्सिमम वैल्यू एक्वायर करेंगे, एंड दोनों की फाइनल वैल्यू 0 जो है वो भी एक ही इंस्टेंट पे होगी. एंड दिस इज योर I naught sin omega t. This is the current which I have shown by a dotted line. You can see here. This is the graphical representation of saying that EMF and current, they are in same phase. Frankly, wherever you are solving a question and you come across this particular statement that EMF and current are in same phase, that simply means that EMF must have been passing through a device which is enclosing only a pure resistor. You understand? So these are the conclusions you have whenever pure resistance has been subjected to an alternating EMF. Now let us consider the second aspects when an inductor has been subjected to an alternating EMF. You next consider that a pure inductor, the inductor has been denoted by the notation capital L. You have already seen that L was denoted for inductor. Inductance के लिए आपने L use किया था. Unit was Henry, if you remember. So imagine that you have a pure inductor coil, which you also call solenoid, getting subjected to an alternating EMF, and as you had done in earlier exercise, here also you have to find out what is the instantaneous current which is flowing into the circuit. Let us suppose एक pure inductor में आपने एक alternating EMF लगाया है and you are interested in finding out what is the current which is flowing into the circuit. Now at this moment, if you are trying to calculate the value of current which is flowing into the inductor, try to invoke the Kirchhoff's voltage law. Kirchhoff's voltage law says that the total potential drop around a loop is equal to 0. So as you have done for direct current, here also you can say the moment you are jumping here, there will be a gain of EMF, and let us suppose the current which is flowing through this inductor is I, then that current will be changing with respect to time, and in that case you can say, invoking your Faraday's law of electromagnetic induction, it had said that L di by dt, this is the potential drop across an inductor. So here you have gained EMF, here you have lost that potential drop, and this is equal to 0. This is the basic equation you are expected to solve. Now if you substitute the value of this EMF, here this EMF is E naught sin omega t, so you can write E naught sin omega t minus L di upon dt equals to 0. Since your aim is to calculate the value of current, so what you can do, it's a kind of, you can say, differential equation. You can cross multiply these two. अगर आप इसको cross multiply करें, then you will be getting an expression di is equal to E naught sin omega t dt upon L. This is the expression you will be obtaining after the cross multiplication of this earlier term. Now to get the value of current, what you will have to do, you will have to simply integrate this total current di, the differential current you have expressed here. If it is integrated, then you will be getting the value of instantaneous current. For the sake of integration, remember that the constant terms have been taken out of the integration sign. You understand here, E naught by L I have taken out of the integration sign, and it is only sin omega t which is to be integrated with respect to time. This is a complete expression you will be getting for the current which is flowing in an inductor coil. Now if you remember, then sin omega t integrated gives you minus cos omega t upon omega. If you simplify this expression, then you will be getting things like this. Now it means that I is equal to E naught upon omega L, and this minus omega t, this minus omega t, this minus cos omega t will be written as sin omega t minus 90 degree, because if you remember sin 90 minus omega t cos omega t होती है, और उसको भी फर्दर आपने रिवर्स कर दिया, तो दिस sin omega t minus 90 will be written as minus cos omega t, and this is the complete expression of alternating current which you are obtaining, which is flowing through an inductor coil. Now you see, यहां पे जो आपने ये एक्सप्रेशन ऑब्टेन किया है, in case you compare it with E is equal to E naught sin omega t, then you see there are some important aspects, very interesting aspects you have here. एक तो पहली चीज आप ये देख सकते हैं, यहां पे ये जो E naught by omega L आपने लिखा है, that is working as I naught, this is a peak value of current, एंड आप वो देख सकते हैं कि E naught को ओमेगा L से डिवाइड करके आपने ऑब्टेन किया है. यू अंडरस्टैंड? अगर आप इसको कंपेयर करें, अगर हम इसे I से कंपेयर करें, आई एम राइटिंग इट एज I naught sin ओमेगा t minus 90, एंड यू कैन सी I naught और ये E naught by ओमेगा L, ये दोनों ही एक्सप्रेशन सेम है. अगर आप इसमें ओम्स लॉ कंपेयर करें, ओम्स लॉ सेज दैट I is equal to voltage upon resistance. So here omega L term, you see this is working as resistance, and you can say that an inductor also offers a resistance to alternating EMF whose magnitude is given by omega L. So what are the conclusions you can draw in this particular circuit? जो भी आपने ये एक्सप्रेशन अचीव किया है, इसके अगर कंक्लूजन्स देखे जाएं तो they are as follows. The conclusions of alternating EMF through an inductor are that the resistance offered by an inductor is equal to omega L. However, this resistance is not called resistance. Now onwards they are called reactance. So resistance now onwards, since we will be calling it reactance, so I am writing it reactance. The resistance offered by inductor is omega L. ये पहली कंक्लूजन है हमारी. माइंड यू, दिस ओमेगा इंटू एल टर्म विल बी हेल्पफुल टू यू whenever you are dealing with dimensional analysis, and remember that omega into L will also have the same dimensional formula as that of resistance. omega और L की जो प्रोडक्ट है वो रेजिस्टेंस के इक्वल ही होगी. सेकेंड थिंग विच यू आर सीइंग फ्रॉम दिस प्लेस, अगर आप इन दोनों इक्वेशन को कंपेयर करें, देन यू नो दैट दिस E naught sin omega t is always taken as reference, isn't it? हमने कहा था कि E naught sin omega t is always taken as reference, and if you compare the expression of current with this EMF, then you find that in the expression of current you have minus 90 degree here. So this is a lagging current. Current is lagging, है ना, because omega t minus 90 है. So second conclusion you are drawing is that current lags the EMF by 90 degree, or you can say pi by 2. These are the two major conclusions. आगे से कभी भी आप एक ऐसी सिचुएशन देखते हैं जिसमें कि एक लैंग्वेज ये मेंशन करती है कि करंट इज लैगिंग द ईएमएफ, सो इमीडिएटली यू हैव टू अंडरस्टैंड दैट इट्स अ काइंड ऑफ सर्किट इन विच इंडक्टर की डोमिनेंस होगी. इफ इट इज lagging exactly by 90 degree, that means a pure inductor has been included in the circuit. But in case it is not lagging by 90 degree, rather by some lesser angle, then you will understand that it is not only inductor, maybe some resistor is also involved, but of course the dominance will be of inductor. So if you are trying to represent it graphically, then remember that if EMF is being represented as a reference, मान लीजिए कि ये EMF की रेफरेंस है, then the current will be lagging by an angle of 90 degree, यहां पे अगर आप ओमेगा टी रिप्रेजेंट कर रहे हैं, इंस्टेड ऑफ टी यू आर रिप्रेजेंटिंग ओमेगा टी, देन इट विल बी एक्सिस ऑफ एंगल. देन यू विल फाइंड दैट द करंट थ्रू द इंडक्टर विल बी lagging by 90 degree, and this is the way it will be shown graphically. For the sake of simplicity, let me mention IL so that it will become very clear that this current is flowing in an inductor. इससे पहले जो हमने ग्राफ ड्रॉ किया था, there you could use the term IR, doesn't matter. So ये हमारी इनकी conclusion होगी. Whenever alternating EMF is passing through an inductor, then always bear that thing in the mind that the resistance offered by an inductor is equal to omega L and the current is lagging the EMF by 90 degree. Now on the similar line, let us suppose we are trying to subject a pure capacitor to the alternating EMF, then let us try to see what are the changes involved there. Let us see that.